Hello everyone, I'm Manavinder from Wayfair. Today I'll be presenting our work on profit-aware ad ranking with relevance constraint. This work introduces a new ranking function in Wayfair's sponsored products program, which is a cost-per-click advertising program designed to enhance product discovery and drive sales on Wayfair. Sponsored products are ad products which are shown on Wayfair's search results page along with other organic products. A common and widely used ranking function in online advertising is peak click times bid, which essentially maximizes expected ad revenue. In this work, we want to design a new ranking function which incorporates both ad revenue as well as profit from sales. In addition, also includes relevance to balance profit. We pose this problem as a constraint optimization problem where our goal is to maximize expected total profit with a constraint on relevance, which is represented as expected conversion rate in this formulation. To solve this, we transform the problem into the dual problem using the Lagrangian method, which introduces a Lagrange multiplier lambda 0. The solution to this dual problem is the scoring function, which is shown here, which has three components. The first two are the profit terms, and the third component is the relevance term. So increasing the value of lambda 0 increases the importance of p-purchase in ranking, which encourages selection of more relevant SKUs. Given W1 and relevance constraint B0, we can solve for lambda using an iterative approach where at each iteration we update lambda depending on whether the relevance constraint is violated or not. And to check for convergence, we track the dual and primal objectives and terminate iteration when the difference between the primal and dual objectives is within a tolerance. Before running online test, we run offline simulations, which involves gathering logged auction data from our production setting, which captures all the candidate SKUs, their bids, click probabilities, and other relevant scores. Then we apply the new ranking function to rerun the auction and compute the key metrics using our counterfactual estimates of clicks and purchases. We repeat this process for different combinations of W1 and B0, and finally choose a few variants to test online. The metrics we use in simulations and online can be broadly divided into two categories. One is system-driven metrics, which are purely based on ranking. And the metrics we use are display price, rating, and review count of the impress SKUs and the bid sensitivity. And the customer interaction metrics involve ad revenue, total VCD, ROAS, and CPC, which depend on clicks and orders. Here we show the simulation results of the two variants we chose. Both variants improve total VCD, CTR, and CVR, with aggressive variant focusing more on relevance. Conservative variant has a minimal impact on ad revenue, whereas aggressive variant reduces ad revenue by a significant amount. We ran an online test using these two variants for 4 weeks, control being our BAU model, which uses P purchase times bid. Both conservative and aggressive variants improved total profit and conversion rate compared to baseline. Aggressive variant achieved higher total profit, but showed a decline in ad revenue due to reduced CPC. We noticed that CTR and CVR increased for both variants, indicating a better user engagement. We can see that online results are directionally consistent with offline simulations, showcasing the importance and robustness of offline simulations. To understand the impact of VCD term in the ranking, we ran another test where we use the conservative variant from the previous test as a control, which has both W1 and lambda 0 term. And the new variant, we set W1 equal to 0, which is the base weight of the VCD term. In this test, we observed a decrease of 2.9% in total profit and other metrics being neutral. This validated the importance of incorporating sales profit into the ranking function. After successful launch in the US, we expanded the new ranking to UK, but saw an unexpected drop in CTR and CVR metrics. Upon investigation, we found out that the issue is related to calibration of P-purchase with respect to VCD. We can see that in the top plot, the blue curve is the true purchase probability, and the x-axis is the VCD. As VCD increases, the true probability decreases, but the calibration probabilities remain the same. We applied a transformation to P-purchase to fix this, and the bottom plot shows that after the transformation, the two curves are aligned. This improves calibration accuracy and also the simulation results. To conclude, we introduced a new ranking function which balances total profit and relevance. We ran an online test using this new ranking and showed an increase in total profit and other metrics related to advertising. In addition, we also identified the critical need for well-calibrated purchases with respect to VCD. For future work, we plan to explore applying relevance constraint at a finer granularity and also work on enhancing the calibration to be more scalable. Thank you very much.